Thank you. Thank you for the introduction. My name is Shun Utsui, and I'm a partner solutions architect working for Mistral AI. So today I'm going to talk to you about Vibe Code, which is Mistral's AI coding assistant, and how it relates to sovereignty and regulated environments. Before I start, I want to quickly do a poll. How many of you are working in an industry or a company where sovereignty or regulated environments do matter? Okay, we have quite a lot. So for those of you who have just raised your hands, this is going to be quite relevant. All right. So I think we can all agree that coding agents today are pretty much awesome. In fact, I'm using coding agents every day, and I really can't think of a world where they don't really exist anymore. You can turn plain language into, code very fast. Anyone can build websites or applications, and ideas can be shipped in minutes. Developers get higher productivity as well. However, these coding agents can come with caveats, especially if you're working in a sovereign regulated type of environment. If you're using them as an individual, you're probably fine. But if you're using them in an enterprise setting, this is where it gets really tricky. So I want to walk you through some caveats that are relevant to an enterprise environment. Caveat 1. So you're basically making API calls to a black box. Every request to a cloud coding agent that you make sends your code outside of your environment. Your environment has, the proprietary source, secrets, API keys, customer APs. These are things that are supposed to be within your environment. The third-party API black box that you see here on the left-hand side has unknown infrastructure, is possibly in another jurisdiction, and you have no visibility and no control. So with every request you're making, you're imposing a risk. You don't know where your code goes or who can see it. You might argue that traffic is encrypted. Come on. But the point is that the internet is an open world, and you'd never really know what can lead to leaking data. And it's not just about a technical matter. With regulated sovereign industries, many companies don't even allow you to access third-party APIs. Caveat 2. Well, Linus Torvalds, founder of Linux, once said, "Talk is cheap, give me code." And now with all the coding agents in place, people started saying, "Code is cheap, give me talk." Well, that was true for a while, until it wasn't. So there are many incidents where, companies are ending up with large bills at the end of the month. Some companies are even saying that hiring a human being is cheaper than using these coding agents now. The problem is really that hitting these external APIs to a black box is really a pay-as-you-go service, and you don't have predictability over your cost. It's hard to set cost guardrails across many people in your organization when you're also in an enterprise setting. Caveat 3, you don't own your AI. Generic models have never seen your world of code. Maybe you have a preference over tools and libraries, and you might have an internal DSL. When your internal DSL interacts with a generic model trained on public data, output usually comes back wrong. Proprietary languages, internal frameworks, edge cases, the model has never seen. A model can never reason simply on anything that it has never seen. So maybe to some degree, you might say that your coding agents or your environment can be tuned by tuning your agentic harness. But that also has its own limits and has a ceiling. Beyond that comes model customization, and you need a specialized model so that it understands your proprietary language. So how do we solve all of that? This is where Vibe Code comes in. Vibe Code is Mistral's enterprise-ready coding agent. It comes with terminal native CLI, it's autonomous, it's project aware. It comes with async agents, so it has write, test, and modify code in parallel without constant supervision capabilities, and it can also validate its own work. We have IDE integration via the Agent Communication Protocol, or ACP, and it can be used with strong customizable models, such as Deathstroke 2 and Mistral Medium 3.5. And you can also deploy this on-prem, meaning that your code doesn't leave your environment, and we can provide it with node-based fixed pricing. Vibe Code fits your core development workflows. So we have basic build, maintain, modernize capabilities here. We have basic build functions like code generation, editing, and testing. You can integrate with your DevOps pipelines and automate code reviews to ship your code even faster. And then finally, you can use Vibe Code for legacy code migration as well. You can do a whole code-based translation from a legacy code, such as COBOL or Fortran, to something more modern, like Python, for example. As I said, you can deploy this on-prem. And for on-prem deployments, we provide node-based licenses. This means that cost is predictable and capped at a certain amount, no matter how many API calls you make to the models that are hosted in your on-prem environment. Also very unique to Mistral is that as compared to the closed source models, we provide the capability for you to use these tools with models that can be customized. So let's dive a little bit deeper into what I mean by that. We've worked with many customers that have hit the ceiling with model performance for their own environment. A very common use case is with DSLs, domain-specific languages, or proprietary languages. Scenarios like these are quite common in industries like finance or manufacturing. And in order to learn those proprietary languages, a human would need to invest a lot of time, and they can only learn these languages once they enter the organization, right? So these proprietary languages don't exist anywhere else. Typically, customizing models for something like this, you would require things like LoRa fine-tuning to keep it simple, and maybe human-in-the-loop feedbacks. But for Mistral, with some customers, we also have gone through more complicated customizations, such as CPT and SFT. After we go through the customization exercise, we would typically then benchmark how we do against a customer's real data set to understand how much better the model understands the language. And we've done it before. This isn't theoretical. So this is an example of a real telecommunication customers we have gone through together in this journey. Unfortunately, I cannot disclose the name of the customer, but this is a customer in Europe that we have worked together with. So the challenge that they had was they had 4,500 engineers working on proprietary legacy code, and they always took up to a week to resolve and respond to technical queries. They typically needed 5 years to become fully productive. And since out-of-the-box models do not understand the programming language very well, developer productivity gains from generic LLMs was pretty much limited. The solution to that was for us to customize the model called Mistral Small 2 for code translation. We integrated this into their existing tool chain and reduced dependency on scarce expertise through automated workflows. What was the result? So we've got 80% productivity gains, reducing millions in cost, reducing time from 5 years to a matter of a few months to onboard a new developer. And you might not see here, but test scores also proved to be significantly better. With Mistral Small 2, which is the generic model, we had a score of only 40.7%, whereas with a co-trained model, we achieved 80.9% on 292 test cases. So I want to actually show to you how this works in production. And this is how it works in real life. So we have two terminal screens here, one on the left, one on the right. On the left, I'm going to show you how a model would interact with a proprietary model that it doesn't know. On the right, I'm going to do exactly the same with a model that has been co-trained. So I'm going to start with the left one. So as you can see on the left one, I'm selecting a model called Mistral Small. This is a generic model that anyone can access. It has been trained on data that is available to anyone in the world. So here, I'm asking it to create a file called program.glyph, which is in a glyph language, which is a proprietary language. And I'm asking it to create a file, emit 36 on the first line, emit 81 on the second line. Now it says the file is created. I'm going out of the screen, and I'm running a test to see whether the file has been created successfully. The test has failed. It doesn't understand the language. Now I'm going to move on to the right-hand screen. So here, I'm choosing a model called Mistral Custom V1. This is a customized model that understands the glyph language. I'm giving it the exact same instructions. So it's writing a file called program.glyph, and it's emitting the numbers that I've specified here. The file has been created successfully. I'm exiting out of the Vibe screen, and I'm going to run the test again. So now you can see that the tests have passed because the model understands the language. So you can probably see that even with a very simple test like this, how powerful model customization can be for your proprietary languages. All right. So this is a bit of a summary slide. What does full sovereignty mean? Well, to Mistral, it means full ownership. And we've been talking to a lot of customers in the region, and our customers in regulated sovereign industries are finding these things to be very critical to their business. First, own your code. We discussed how hitting an external API outside your environment could be a risk, and how an on-prem solution could help. Own your cost. We discussed how a node-based license could help you with addressing the high cost at the end of the month. And then finally, own your AI. You can tune your agentic harness, but it has its own limits. Beyond that comes model customization. So start thinking about what's important to you and how you can protect your important assets. And if any of this has resonated with you, we would like to talk to you. Thank you very much.